Okay, we start. Woo!
Hello guys, my name is Yang. So our team is develop a system which is called LeRobot. So namely, it's human robot service system with generative model. Okay. So is there? So next. So this is a system. So I will say the motivation is that people avoid to use traditional control method like PD controller because it's so difficult. It's hard coding. It's a lot of feature engineering. So the first idea is we want to train our policy, but we think there will definitely a sim-to-real gap. So we choose another method. This is like a whole framework. So we first we emphasize that it's like human robot collaboration system. So there's remote people. So to teleoperation to pass the target goal to our LeRobot through the thrower. Then we use large language model to command the thrower, and the robot can understand the command. And then we also have a camera system which can track and locate the target where we want to throw. Then we put it in the flow matching model, which is conditional flow matching model, which is generative model, so that we train by the.
Thank you very much.
Okay. So we can see it's tracking the ball and okay. So this is during the simulation we use R to train the expert trajectory, and then we command the robot and can throw to the target. So here you can see so here it's me. We will pick the ball and pass it to the thrower. Then we use so the large language model can analyze and give back the JSON file. So it's right and throw. So
Amazing! Thank you so much. You are the first to watch the video. Woo! You got it. Do you have 209 team here? The team which is called Tyro. Do you have a team? Where did you submit it? Where have you submitted? What? You guys, I just asked with numbers, just numbers. Very simple to find them. Oh, God. Okay. Okay, sorry. And now present. Okay, here we go. 1 minute.
All right, hello. So we want to help solve the pill picking problem of Parkinson's patients. So because like in the later stages they're hands get really shaky, it's really difficult for them to pick pills. And so we thought that the robots we got are a really good opportunity to pick the pills for them and put them somewhere in their close to their mouth so they can just grab it with their mouth. And the biggest problem was that the gripper wasn't supposed to grab tiny objects like pills. So our biggest contribution is to redesign the gripper. So we 3D printed a new gripper, and with that it's much easier to pick small items like pills. And we also started training. Unfortunately, it didn't finish soon enough, so we have the parts and want to, for the global hackathon, combine them all together in the next 2 hours. But for now, the gripper is our main contribution, and the other parts are following. And the idea is that the patient can control the whole thing with voice commands. So he says or she says, give me the pill, for example, and then the routine gets triggered, and the robot grabs the pill and brings it in close to the mouth. Yeah, that's it. Thank you.
Hello, welcome to the Thyroid Tube. Our idea is to help Parkinson patients to take their pills because they have this problem of shaky hands, and so they can't take their pills anymore, and this robot can do it for them. So the first thing we did is to optimize the gripper. We printed our custom pill-taking gripper that's way better at taking pills up than the original one. So here, just grab this one, and for the original one, it would already have fallen down, which is not possible. And this, you can see it, grabbing is really good. And the idea is that the patient can control this robot with voice commands. We have a script ready there, and we recorded also the data set, and now we're waiting for the training to finish and hopefully combine everything in time for the worldwide hackathon deadline.
Thank you so much. And the next team.
Guys,
Robot go brrr. Brrr. Oh, I don't know why.
Guys, please stand in line here. You know when you're coming, right? So it's going faster. Thank you.
Alright, so hello guys. All the team, hello. Alright, so our team Robots Go Through, we originally had the idea to make a laundry robot. So yes, sometimes you have just a large amount of laundry piled up and you don't want to fold it. So we tried to make this robot do it for you. Yes, and what we try to do, the approach is that we have an RGB camera mounted on the wrist of the robot arm, and we use imitation learning, so we recorded episodes of the folding movement, and then later trained it on hugging face. But unfortunately, it did not work out. And yeah, actually, and also originally we tried to utilize the Intel RealSense depth camera. We tried to use the depth feature, where we got a really noisy depth map, and we just tried to use a medium filter to stabilize the voice, and then use anyways, it did not work on it worked on my computer, but it did not work on rerun. So we don't have a finished product, unfortunately.
The next team, thank you so much. The next team, 211. 211. Slides, okay. Here we go.
Thank you very much. Timer, go. So we're team manual override. We wanted to give LLMs hands. So we built an MCP for the robot models. Next slide, please. Imagine you have a prompt like prepare my bag for today. VLA is good at picking an apple and putting it into a bag, but it doesn't know that you have a calendar invite for a whiteboarding session, or that the weather's sunny, you're taking the bike and you want to take your bike ride. So we built an MCP which has a fine-tuned small VLA, which is still training, and gave access to Claude. So Claude can go introspect its environment, look at what robots it has, use multi-step planning and reasoning over n robots, n equals 1 in our example, and we get all the goodies from being an LLM. You get real-time data sources, you get state-of-the-art reasoning, you can parallelize over robots, and you still have VLA for physical actions. Next slide, please. Applications are wide, and yeah, just a little detail. Our OpenVLA is still training, so we have some teleop demos in our video. We have a nice storyline though, so stay tuned. And the MCP does mistakes sometimes. That's it.
Go!
Do we have audio for the video? We made a really nice voiceover and everything. Can we put on the audio for it? Otherwise, I can just do it live. This is Manuel. He's busy, he's working, and you'll soon notice that he didn't pack his bag for work. Average robotics engineer, take this.
Our MCP server allows language models like Claude to act and intercept through multiple robots by exposing an MCP server, which has a fine-tuned small VLA model to convert from instructions into physical actions. This gives us access to real-time data sources and context about the user, and leverages state-of-the-art reasoning capabilities that allow us to plan and execute over multiple robots. While Manuel is getting ready for work, not to get to work at the back, we'll think about what things he has in his Google account for what he's doing tomorrow. After that, we'll use MCP to get description of this test, then pick up these things using the robot. And by the time Manuel is ready for work, the bag is ready to go.
So this is teleop. I can give you the weights and biases link. It's training, loss is going down, everything is fine. This is fine. And the robot is packing Manuel's bag, and then Manuel can get ready for work.
Thank you so much. Where are you? I don't see. How to find? Okay, maybe I refresh. Oops. Still not here? Guys, you see, it's very important to have the number first. Just number, it's very simple. You can submit one more time. Oh, biohackers. Here, okay.
Hello everybody, so I'm here to present the work of my team. It's called Biohackers. The name is quite irrelevant, but our goal was to look at an image and then know what is in that image, and also exactly get the coordinates of the objects based on a user prompt. So can you go to the next slide, please? Yeah, first the user gives a natural language input. And then the full computer vision model, it segments the image, and for every segment, we do a labeling, and based on the labeling, and the user input, we match which object matches the most, and we return the coordinates, and the final goal is for the robot to pick up that object. So yeah, for example, in this case, we used a lot of animals because the pre-trained models that are available, they do work well with animals. Because they are trained very much on animal pictures. In this example, we have a couple of animals, and then we take a picture, and then the input prompt here is the desert animal, and you could see a camel there. So the model is able to find 9 animals, and then the most relevant one based on the user input is camel, and we get the output of the coordinates. You could see here, that's the XY coordinates. We didn't do Z because... Thank you very much. coordinates, but working out the inverse kinematics was kind of difficult. We couldn't like exactly get the robot to go to a particular point in the 3D space. But yeah, that's it. So we got the coordinates, but we couldn't have the robot.
Thank you. The next team, 213, right? Do we have this team? 213 is here? Okay, no, 214. Woo! Woo! Where are you?
Hello?
Hey guys, please, thank you.
So, when I first saw these amazing image generation models, I think, how amazing would it be if we can build a robot which can paint these images? So, I will present the painting the robot. So, our pipeline. We want to transform text to speech to text. We want to generate from this text an image. From this image, we want to downsample so that we can extract the most important colors. With these colors, we generate trajectories, and these trajectories we want to put into a robot, which can then pick up pen and draw the image, and this cycle will repeat with each pen. So our hardware components. So we designed our own custom gripper because picking a pen was not so easy. And yeah, let's see our live demo.
Is it also called the painting something?
Yeah.
Or is it like another Okay. You can resubmit and we will give you a chance at the end. $215.
Yes. Presenting to you the board about how to make robots lose money by team. I'm working with Angel. So don't you think that casinos have always won since until now? So it's time to change it. We introduced PokerBot, which is the Greek robot, which can play a simplified version of poker. It can fold its card, it can call a bet, check, and show its card. Everyone keeps saying that the ChatGPT moment for robots are around the corner, but it's not. For the ChatGPT moment for casino robots not around our corner. Because now you can see that we are really confident in the future of humanity gambling. So you know how AI has been taking our jobs? They are taking my software engineering job. So I think it's time for us to win money from them. We want to leverage the hype of AI to make a poker bot that loses VC money, specifically. By having this robot, we can maybe reduce human addiction because they're going to be too bored winning all the time, you know? So next one. So this is the boring part of how it works. We collected the data, we have our Poker GPT proprietary engine, we fine-tune the root model, and then we win the money. All right, thank you very much. So you can see the video here, how we show the robot the cards, and then you can see my feet on the top there. So so we have some parts of the model working, some are, so almost working. So these are just clips of the successful parts, the good parts. Obviously, we only take the good ones. So this is folding, and then we can show that it's done, and then it showings the card, and then you win. That's it.
Next team.
Partially you can take a few seconds away from my team, but from my time, but I want to say something again to reiterate the point early on. This was an awesome event, guys. This was awesome, great. And I've seen some part of work in the background, and I know a lot of people work very, very hard on this for us to get this organized, to get this arranged. So please join me again. A round of applause for all the organizers. Thank you guys. I have 20 seconds left, right? Alright, let me start. Meet Spar, your sparring partner, your sparring robot. And the idea is, and I'll leave you here with one number, 700,000. We can flip to the next slide, thank you. 700,000 people in the world practicing fencing actively. And if you think about reaction-based sports, we're talking about millions of people. The fun part of that sport is where the challenge, you need a partner. So what happens if the partners are around, sick, working all the time? No training? No. You train with our sparring robot, you spar. Next slide. And on top of that, we also had one unique approach. We only used one arm. We used one arm, the arm control, and train with that and teach them fencing. Now imagine, this is just a small arm, but imagine that arm bigger, that arm more flexible, more intelligent, and it's in your home, right? Don't you want to train with such a robot? Thanks. That's not me. Thank you.
Meet Spar, our future sparring partner. Our approach was here very unique. We used a VR headset to train the follower arm. And together with the feed of different cameras like the RealSense and its depth camera feed, we collected a very unique data set to teach this robot arm how to do the sports fencing. Now based on this data set, we then trained an ACT imitation model, and as you can see now in this scene, it automatically reacts to my move and try to counter my fencing attack. Spar is a revolution. It's your new sparring partner, no matter whether it's fencing or even boxing in the future. It's your reaction-based companion. Enjoy.
That's how the whole war started. The next team, please. Which number do you have already? Up? 217. Okay, good. You can start talking and I'll.
Okay, we are thinking beyond. We designed a robotic arm to pick up a snack from the table and successfully deliver it to a person's mouth. It's designed for mobility impaired people to help them eat more independently. We obviously started with all the technical difficulties, calibrating and gaining all the data yesterday. And we were able to put it into the model overnight. So with 120,000 steps, we gained a pretty confident model this morning, and then also implemented it successfully. We now have a robotic arm that can pick up the salt stick and deliver it to a certain position. The next slide, please. And to give a quick outlook, we also plan on grabbing cutlery, different things, and also installing it on the wheelchair for these impaired people to use in their everyday life constantly, not just at a certain table. And we would also then like to implement a camera on the robot, since this two-camera environment is not always accessible everywhere. Thanks. We got inspired by everyday challenges in assisted feeding, how a single bite can mean independence. So we asked, can we teach a robot to deliver that bite? We used the robot's ACT policy and implementation. We recorded 66 episodes and trained a model that follows like an apprentice. The challenge, consistency. It's not just about picking things up, it's about finishing the gesture. Our system doesn't stop at good enough, it completes the job. We trained the model overnight, 7 hours, 140,000 steps. And this morning, it worked better than ever. We designed this for real-world impacts, so that even someone with paralysis can enjoy a snack again. Our model is lightweight, trained in a few hours, and works with just 2 cameras. It's simple to teach, easy to use, and powerful where it matters most. We learned that when innovation meets intention, even simple setups can get far. Because feeding is care, especially for people with disabilities who rely on systems every single day. We are thinking beyond, and this is just our first part.
Fantastic. This team even has the same t-shirts.
Yes.
The next team, please. 2018. Oh, 218, sorry. My English numbers are so good. You can start talking about the one.
So, hello, we've all been humiliated before by chess engines on our phones. So we wanted to bring this lovely experience to reality, and therefore we, the Blitzers, are presenting our robot. At first, after we make a move, our robot uses our own segmentation CV algorithm along with a VLM to scan the board and find the current state of the board. And then using this state, we use a chess engine, Stockfish, to predict the best next move. And then since each move is picking a piece, moving, and then putting it somewhere else, we train 2 models, one for picking and one for dropping. And unfortunately, it worked. So no teleoperation happened. We can be back in Munich, and the chess engine can be humiliating you in chess. Let's see the video. We fine-tuned 2 small VLA models. This is a scanning experiment. This is our player thinking the move. And then the algorithm is able to predict the move and know what the state of the model now, so the board now is.
Good job, Ed.
Good afternoon. All right, so I'm from the team Grasp Trash. So, summer in Bavaria is about 3 things. beer, barbecues, and beautiful hikes. Unfortunately, people aren't that considerate and leave their trash all over the place. What's the best thing to do? Just make a robot that can actually sort, identify, sort, and clean trash up. Next slide. So this is what Grass Trash is. It's generating random anagrams for a straightforward project. Trash to recycling appropriate sorting heuristic. And yeah, we use 2 cameras, Context and a wrist cam, to and then we fine-tuned the small VLA model to make our Grass Trash model. And next slide. Yeah, and then we just run it and inference time. Now, unfortunately, like many of us, we couldn't get enough training in, but yeah. That was the concept, and we can navigate and pick up trash, identify trash, sort it out, plastic and paper trash, and predict trajectories. So yeah, that's it. Thanks. Woo! So the video is a very, very small clip of this actually happening at inference time. Unfortunately, an hour before, the robot suddenly broke down. I swear I didn't break it. But yeah, so the demo is unfortunately just that much. I would like to take 30 seconds to just thank all of the teams who helped us out. Our entire team was made of people who didn't actually work with a robot ever before, and we got so far, so we're all super thankful, and thank you guys so much.
Thank you so much. Do you have the team 220? Very nice. Come here, come here. Where is the slide?
Guys, again, be ready here in front, please.
Yeah. Hi guys, we're team LeRobot. So, how many of you guys loves traveling or loves going to hackathons? But who also likes taking care of plants, loves decorating her windowsills? I'm one of you. So, but whenever I come back from these trips or these events, I found my plants either wilting or almost dead. So, during the past 24 hours, we didn't sleep. Instead, we created, like this. So, we created a robot, an app, as well as a model that recognizes cups with water and picks it up, waters your plants, and puts it back. I hope you can try it out at home, and this app is also connected to a voice assistant on your phone, so you can connect it, but you can control it anywhere in the world. So let's watch our demo video. Where is it? The same name? It is with brackets. This one? Yes.
Nice to location. It's old. An air program like that. I think it's gonna die. It will be the third plant this week. Yeah, it's good that I programmed a very nice high-tech environment in real time. Hi.
Hey there, how can I help you today?
Could you please water my plant?
Alrighty, your plant is being watered right now. Soon it will be happier than a sunflower in July. Till next time.
Thank you.
Thank you so much. Do you have this team? Okay, how to find you?
Okay. Hello everyone. I hope you are doing well. My name is Yasser Salim and we're going to be presenting Luminix, our solution to provide new content creation. So this is our humble but very humble team. We try our best. And I'll just present an idea. So imagine you're sitting at home watching TikTok videos, everyone does that from now and then, and you just see the same old content just again and again. We provide the solution to new content generated by robots. So everyone knows the ring light, the one that everyone uses for TikToks. Most of the people dance around it. It apparently has a lot of sales, and we want to make money. So our robot provides the perfect lighting based on imitation learning. So next slide. So yeah, we used our solution is called Luminix, and we used imitation learning to train the robot to provide the perfect illumination to your videos. So we can just skip to the video.
Thank you very much.
Okay, so this is a very beautiful lady applying makeup, and we see a lot of content like this. And yeah, she's applying her makeup. She's saying, "Oh, you gotta buy this blush. It's very good. You gotta buy this mascara. It's awesome." And instead of having this ring light, now you can record your videos and light it very well using this very smart robotic arm, well trained. This is the light. Can be replaced to a better version, of course, but yeah, for the budget reason, this is where we started. And yeah, you can see this is the point of view of the robot. In order for the robot to not hit you in the face, we used the depth camera to keep a very safe distance. So yeah, that's it.
Okay, Eva Troll maybe next, right?
Hello. This is going to be fun. Full disclosure, I haven't seen those slides yet. But just to keep it simple, how many of you have teleoperated a robot today to collect data? Okay, I see a lot of hands. It's a lot of work, right? So wouldn't it be amazing if we just have someone else do it? Well, actually, wouldn't it be even better if we just pay you guys to do this stuff? So next slide, please. Oh yeah, exactly. So that's basically the problem. We have a platform that we integrated with where we connect gig workers to the robots. It's like Uber, but think for robots. You can sign up, control the robot. Next slide. And it's as easy as what we've done here is we've built a simple integration where you drop in to place a leader, you create a task, and then someone else from our platform will come, connect, do it for you, get paid. You also have to pay them, right? This is how it works. And I guess we can go to the video. I think the video will be more fun. Oh, can we do version 2? Yeah, there we go.
Find it.
Got it. So see, this is one of our fantastic team members. He's been working hard for many, many hours. And at some point, he just couldn't take it anymore. He was too tired. So he gotta call some of his friends. And yeah, so he called up Wolf Robotics. And well, again, this time it was me, not one of our gig workers, to the teleoperation. And we connected remotely through WebRTC to the robot and teleoperated. I think here, we usually do for our customers stuff in simulations. So it was actually our first time connecting stuff to hardware. So the video streaming, super hacky. I would have loved to have stereo streaming, and that will come later another time. See, it's kind of hard to get the depth data here. But there you go. That was the task. Here I had to put the ball into the trash. Thank you.
Great job, thank you. Do we have the next team, 223? What is your deck?
Does it work? Okay, hello everyone. So our team decided to tackle a problem that's tedious and annoying for makers and electronics hobbyists everywhere, and that is soldering. Although it can be fun, but for the people who don't know what soldering is, it's basically do I need to hold it close? Yeah. It's basically putting electronics components on printed circuit boards. So to make them work, basically, get them power and everything. And for those who've done it, they know that 2, 3, or even 4 hands are barely enough for this process. People are known to use these kinds of things, which are called literally helping hands, and they're used to hold the boards in order for things to be soldered on them. And we thought we could make them a bit smarter because they're usually very annoying when you need to switch the side, when you need to move it a little. You usually have like a component in one hand, a soldering iron on the other, and this can be very annoying to grasp all of this and put it all in one place. So that's why we made the helping hand. We'll come to that. Next slide, actually. Last minute submission. Next slide.
Sorry. Hard stop.
Yes. And the concept.
Sorry, it's hard stop. Hard stop. But we can show you video.
Can you show you video?
Where is it?
Yeah, sure.
Where is it?
Should be with, yes.
Hello. So this is Norman. He's been soldering a lot recently, and it's been very, very annoying for him to solder things. He's using those helping hands that are super annoying to deal with, to set up, to when you need to move the board, it's annoying. This is Abdullah. He's smart. He recently got a helping hand, a new helping hand, and it helps him solder. He can do it just with voice commands, and looking at it's much easier to look at it and test things and look at things this way. Actually, for our team, this is what we've managed to do this far. The other demo was teleoperated. This is what we've trained. It can pick up a PCB board. It learned to do that. Shout out to our great team. This is Norman, amazing guy, chill guy. This is Steven, very smart. This is me, very, very smart. He did this before actually too. And this is Abdullah, very frustrated. Autumn couldn't be here for the video, but she was amazing.
Shout out to her. She was sick today, so that's why.
Thank you, amazing. 2 to 4.
You know, it's really frustrating when you come to a hackathon expecting to build a really cool robot, and then you just spend the whole time looking at runtime issues in your terminal. So that's what happened to us. We tried to fix it until the very last moment, and that's why we only have a white paper, no nice slides. And I'd say it would be great if we had built a robot that cheers us up because we're a bit frustrated, but that's kind of what we tried, so let's just look at the video.
When 1/3 of the adult population are speed only, that's only going to get worse, especially for elderly people, if there's less and less caretakers available. So whether we like it or not, we will need robots for taking care of especially old people. And so we thought we built an emotional or emotive robot that gives you a sense of physical touch, which has been shown to us as to be really important for health and overall well-being.
reader and a follower robot. Reader shows what exactly the follower is doing, and we take a pre-trained model, pre-trained vision language action model, and we fine-tune it to do our task. That's how we talk.
Thank you.
Thank you. 225.
Hello everyone, my name is Daniel and I'm presenting on behalf of the team called Get into the Robot. We are co-workers, colleagues at Intel, 4 people was in our team, and we are presenting LeRobot. The main idea was to create an interface, speech-to-speech interface to LeRobot, and we decided to make LeRobot. He does two things good. The first thing, it can speak with you, it answers, and it mimics something, like he can say yes, no, he can like do some stuff, and in red, he can even be activated, and as a good pet, he could bring you a ball. Please, next slide. For training, for the speech-to-speech, we used our Hackathon face repository, speech-to-speech, and for training, we used basic model. And let's.
Hi guys, was very to do that, and bye from us. Bye.
That's the Brazilian team on your Zoom.
This is
yeah, let's leave first. Yeah, let's leave first. Okay, so we go.
Yeah. Let's watch the video.
So, Robert, what is your name?
I'm LeRobot. Nice to meet you. Steve.
LeRobot, could you please bring me the ball?
Get ball.
Oh God!
Speaker boy, beep boop. I'm LeRobot. Your friendly crocodile robot. Yes, I'm a good boy. Don't worry. Chomping sounds.
Do you know the capital of Great Britain?
Yes, London.
Correct answer. It was a correct answer.
Yes.
And plus 2 equals 5, right?
No.
If you can say no.
2 plus 3 equals 6.
No.
He's not too smart yet. He's only 1 day old, so.
Yes, that's correct. Team 2.
Yeah. Thank you.
So that's it.
Thank you.
That's it.
I think like everybody has seen pictures like this. The trash. I think like everybody has seen pictures like this. The trash problem is becoming bigger and bigger with every year, and our solution for that is trash bombing. We're using 2 SM100 arms. One is on a mobile robot that's like looking around for trash. The SM100 arm picks it up and gets like back to the base, as you can see here on the right. The base classifies if the trash is like paper or plastic. Plastic is getting into the right bin and paper into the left one. Now let's get into our training workflow. Yes, basically we have to train 6 different tasks. 3 for paper and 3 for plastic. They're basically the same, like picking up the trash, drop it, and then sort it. And then, of course, find new trash. We use small VLA for fine-tuning this, and small VLA is like perfect if you have multiple tasks, because it actually makes the performance of each task better. Okay, now let's get into the video. Like, see you. Yeah.
object classification detects if it's paper or plastic, and based on that we start like different policies. And now it's detected it's paper, it's picking it up, and the wave rover, like our S100 arms on top of that, is moving back to the base. It's hard-coded right now, dropping the trash. And now the second S100 arm knows it's paper, and because of that, it's putting it on the right bit. And yeah, paper was easier than plastic. In the next step, we can see plastic. And to be honest, like even teleoperating this was super hard. Like so, big applause for our team working a lot. That's a whole lot. And yeah, as you can see, we are better than Grass Crash, who copied our idea. So yeah. Yeah, let's make the world a cleaner place. Let's go.
Thank you. The next team.
Hi guys, we are Team Ninja Turtles United, and we came to the Hackathon to tackle a very specific challenge. As many of you know, what is the problem that is stopping the robotics community from having their ChatGPT moment? Well, two of the large problems is that first is compared to large language models, there's just not enough data out there to train the robots for generalist robot policy. And the second one is we actually don't even know what are all of the modalities that are necessary for the robots to learn this generalist policy in the first place. And during the hackathon, we basically decided to make two contributions towards making this process easier within this amazing LeRobot framework. So the first one that we managed to do was that we created the asynchronous depth read using the RealSense camera. This means that inside the LeRobot frame, you are now able to get the depth information. And one more thing is that the uploading function also works, so you're actually able to share all of the depth information to the cloud so that other people can actually use it. And the second one that we decided to do to reduce the barrier was in simulation.
Yeah, so we haven't talked about simulation much. I can go to the next slide. But it's actually quite important, right? So why are we all here? Because you know, we don't have enough data to train it, but simulation can help us here. We can basically you know, scale infinitely with simulation. But you know, when we train there needs to be an easy way to go to the real world. And we build a digital twin, which actually lets you go easily from, you know, scale simulation to the real world, and also has the same control interface in the real world to let you scale up the collection. But to really have also our ChatGPT moment in the robotics community. Thanks.
So we actually kind of ran out of time for creating the video, that's why the video kind of looks exactly the same as the pitch. But as once the video comes, then we do have moving parts, so don't worry, it's not all going to be just slides. Yeah, it's a little bit more.
So shall we?
Yeah, it's fine, okay. So this is basically the first contribution that we were talking about, having the left camera interface be working inside the LeRobot interface, and as you can see, you can also visualize it in the Rerun interface. The flickering is just due to a visualization bug, and we had to wait, yeah.
This is the second contribution, our digital twin. You can see here on the right above, the digital twin in the Mujoku simulation is moving exactly like you're moving in the real world, and with that you can also collect in the simulation and try to train a policy in simulation and in real. Thanks.
Thank you. The next team, please.
All right, good afternoon everyone. Thank you for having me here. I'm pleased to share with you what we did over the period of last 48 hours. So we developed Lay Detective Da Vinci. Basically, this is a robot that takes user input and over an LLM, takes features of human face and then designs and draws a portrait out of it using LeRobot. So the user can tell what the eyes are like, nose are like, lips are like, and based on this information, it takes pre-recorded features and then paints a face out of it. But why stop there? We are here to learn more, to see what we can do with LeRobot. So we went ahead and we did imitation learning. And with imitation learning and soft body manipulation, we also taught the robot, did the training to pick up the sponge and then erase the portrait once it is drawn completely. So yeah, thank you. That is our project. This is the voice input example. I couldn't see him well, but he was running really fast. It looked like he knew exactly where to go. He was big and tall. He has eyes like this, face like that. So this is the kind of input that you can give to the voice element. Thank you. This is our distribution. So as it decides what features it has to draw. I would say it's pretty good. It's better than me drawing. I would say for a
Thank you. The next team. What is the next number? What was the last, guys? Why don't you put the numbers? Okay. 26. Okay. 26. Are you ready? 26. Guys, los compas. 29. Okay, 29. Good. Okay, 30. Do we have 30 here? 31?
Yes.
31. Okay. Okay, you have two presentations. Which one? Any? The same. Just to confuse me completely. No. Yeah. Sorry, I'm too strict.
Hi everyone. First, a big congratulations. You almost made it. So on this long weekend. And imagine that you finally got back home after this long weekend. You are super excited but tired. You toss your key at the hallway table randomly, and you don't ask or press any button. A quiet robot just quickly collects your key and collects it to where it belongs to. Next slide, please. And that's our JellyBot. It can be a part of your home and help you to make your daily life much tighter and more organized without extra effort or internal friction. Next slide, please. We have a simple setup which uses a LeRobot arm mounted on a hallway table. It sees through 3 RGB cameras at width, top view, and side view. And we collected 20 episodes of high-quality data and fine-tuned a small VLA model. And next slide, please. And in the real-world setup, if we have exactly the same setup, we can achieve nearly 70% success. It should be a GF, but it doesn't move in PBM. But of course, real world is not a benchmark data set. Of course, we still have so many challenges to tackle, and also we have more vision to achieve. Next slide. And we also have a video. Very bottom. This one? Yes, exactly. Thank you.
Thank you.
Okay, 32. Virani Bot.
Hi everyone, I guess everyone is hungry, right? Everyone wants to eat something. So I like biryani, I don't get this food here. This is just not my problem. There are 15 million people with spinal cord injury who can't cook, and there are 6 billion people who don't want to cook, right? So this is what we want to do. You tell it will take homemade fresh food, and again, advanced technology is not available to all. We want to make it available. What it does, yeah, this is what we did. 2 days, we don't have slides because we made so many experiments. What we do is, we take a YouTube video, we generate the commands for it, then we also did digest. 70% of the people could not run with small VLA, right? Because it's not good. What we ended up doing is, we built a world model, we took 3 RealSense cameras, added more data sets so that our project would work. Next one. Okay, yeah, and all our code is here. So what we basically wanted to do is, you can take this code and run it, and it works. You put your favorite video and it will work. Yeah. So you see, this doesn't work. Why it doesn't work? Because the algorithm is not as good, and you can come to us, our desk, and we'll show you how the 3 RealSense cameras work. Because the quality of the camera is not good, everyone struggles with it. So what you do, you add more cameras. Our desk is at the bottom, at the back. You can come and check it out. Thank you.
Next team, please. It's the last team, right?
I think, yeah, that's the last presentation. Let's have some fun. So please don't take it seriously. Initial idea was simple. Let's take a picture from the camera. Let's send it to LLM or ELM, and let it decide what to do. And after that, we can prompt it to our SO1 app and do it. But actually, it was too complex. That's why we decided to add some fun here, and let's repeat. Sound is important here, so please. No, it's not mine. It's not mine.
The idea: analyze the picture, decide what to do, and do it.
Oh, I see. We need to pick up the orange object and put it into the box.
So it's decided what to do, but let's look at the result.
Is there any team that we missed?
We still have to play that one video.
Ah, the one video.
Yeah.
Generate a tree within any node. We have here the resulting image. And for example, here we have the color map. And the color map is translated into a trajectory. For example, again for orange. And we want to transform this trajectory to these robots.
Yeah, unfortunately, our model was not finished training, so this is stereo operated. But yeah, maybe if we do another all-nighter, we get it work.
So yeah, thank you.
Hey, thank you so much. Amazing work, guys. So now we will give our jury to discuss this amazing project. It's really, really hard work for them now. I'm really not jealous of them, to be honest. So in 20, maybe 25 minutes, once the guys decide who will be top teams to present their live demos, we will announce that. If you believe you will not get to the final selection, you can probably start to returning hardware and getting your t-shirts. And please again, clean your tables, clean around, help our volunteers, and socialize or keep working on your project and submit to the global hackathon. Thank you so much.
Where do we want? Is there like anyone we haven't tried yet? I think Daniel and I are just gonna try it.